Welcome back. This is your teacher David Garcia, and today we're going to work with the system of equations problem process as an approach to solve word problems. So let's get down right into it. The problem reads, the school that Amanda goes to is selling tickets to the annual talent show. On the first day of ticket sales, the school sold 4 senior citizen tickets and 14 child tickets for a total of $112. The school took in $110 on the second day by selling 7 senior citizen tickets and 3 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. Now, the idea here is that if you remember, we normally work with system of equations in which we have an equation expressed in this way. We have 2 variables, and then we have a number in here, whatever the number. And then we have another equation that looks very similar, something like this. This equals to a different number. And then by a process of elimination or substitution, we make these 2 equations relate each other, and we solve the problem. It's very straightforward. Now, the idea here is that the information that we have in here has to be written in a similar way to these 2 equations. So the idea here would be to identify the variables. So let's see. We have senior citizen tickets. That's one of the variables. And the other one is child tickets. We don't know the prices, and that's what we're trying to find out. What we do know is that the combination of these 4 senior citizen tickets and the 14 child tickets, that gives us an amount of $112. So if we call the senior citizen tickets our variable S and the child tickets our variable C, then we can come up with this idea that 4 senior citizen tickets and 14 child tickets equals an amount of $112. Now we do the same for the second one. We have $110 as the result. And this comes from 7 senior citizen tickets and 3 child tickets. So we have 7 senior citizen tickets and 3 child tickets. So I'm going to solve this system by elimination. I think it's probably the easiest one. So if you see, I'm going to start eliminating this S. So if you see, I have a 7 in here, which is a prime number and an even number, all right, that is 4. So I will just have to multiply them. So I'm going to multiply the first equation times 7. And the second equation times, in this case, -4. So I can cancel the S variable. So let's begin. 7 times 4, that's 28S. Let me do this so we can identify them better. 28S. And then 7 times 14 will be 98C. And then we have 700, 17, 14, 784. Now we're going to do exactly the same thing with the second equation. In this case, it'll be negative 28S minus 12C. This equals negative 440. So now we have both our equations ready. And by doing this, you can see that the 28 will get canceled. The 28S will get canceled. And now it's just a matter of having 98 minus 12, it's 86C. and this equals 344. The 86 is multiplying, it will go to the other side dividing. So 344 divided by 86. Let's put that in our calculators, and we have that the value of a child ticket will be $4. Here we have our first variable already. Now, if we want to find the value for the other variable, it's just a matter of selecting one of these two equations and substitute the cost of a child ticket into the corresponding variable. So let me copy this equation right here, and let me bring it over here. Sorry about that. So this, let's isolate the S. So this 3C is adding. It will go to the other side subtracting. So 7S will be 110 minus 3C. This 7 is multiplying. It will go to the other side dividing. So my variable S will be 110 minus 3C, and everything will be divided by 7. So I can do now the substitution. S will be 110 minus 3 times 4, and everything will be divided by 7. So my S equals 2, let's put these in the calculator, $14. So I have the price of my senior citizen ticket. Now, let's do another problem, a little bit different. I have it right here. This problem reads, a plane traveled 1,260 miles each way to Lagos and back. The trip there was with the wind. It took 10 hours. The trip back was into the wind, so the plane had to fly against the wind. Obviously, the trip back took 18 hours. So if you see, it took more time. What is the speed of the plane in still air, and what is the speed of the wind? Now, in the same way as before, we have to identify both variables. Now, if you see the main idea here is the speed of the plane. So we can call the speed of the plane one of the variables and the speed of the wind the other one. So this will be the plane will be P, and the wind will be W. So in the first idea, we have that the speed of the plane and the speed of the wind, because they were going in the same direction, they covered 1,260 miles. There we go. They covered this distance in 10 hours. Now, I'm writing the units in here because it is important that we respect this equality. If this is the speed of the plane and this is the speed of the wind, obviously we have to make them equal to another speed. So in our first equation, we will have that the plane plus the wind equals 126 miles per hour. Now, in the other, in the way back of the plane, going back to the city, it covered exactly the same distance. The distance will not change. What changed was the time. Because now the plane, speed of the plane was going against the speed of the wind. So it covers again the same distance, but that distance took more time, in this case, 18 hours. So now we have to divide 1,260 divided by 18. And let's put that in the calculator. That equals 70. So the second equation will be like the speed of the plane plus, minus the speed of the wind will be 70 miles per hour. Now, the easy part of this problem is that if we do this addition, we don't have to modify anything else, right? You can see that the wind, the speed of the wind will get canceled automatically. So we will have that 2 times P will equal 196 miles per hour. Now this number 2 that is multiplying will go to the other side dividing. So the speed of the plane will be 196 miles per hour divided by 2. So the speed of the plane will be 98 miles per hour. There we go. Now, in the same way as in the previous problem, it's just a matter of substituting this value into either one. Now, I think this one is easier because we don't have negative signs. We don't have to worry too much about changing this number twice. So let me take this one right here, and I'll do the substitution here. If the speed of the plane plus the speed of the wind is 126 miles per hour, then this speed is adding, it will have to go to the other side subtracting. So that means that the speed of the wind will be 126 miles per hour minus 98 miles per hour. So this will be 88 and 2, 28 miles per hour. That's it. We have the speed of the wind. And that's it. Thank you very much. And I will see you in our next video.